Buongiorno a tutti. Unfortunately, this time I will speak in English. I'm pretty sure you will be able to understand and approach me later after my speech. So first of all, thank you for being here. I'll try to be very quick and efficient in my speech. Today, I'm going to talk about not only flood modeling, but also using technology as a source to map human sensor products. Today, in this technological world, we are more than human beings. We are human sensors that with our phone, we're able to provide information to open platforms. And this is very important that we could integrate into our models, not just from the scientific point of view, but from the human perspective as well. And we are taking Palermo as a case study to really understand how social media and videos from citizens can help us improve our understanding on flood hazard and flood risk. First of all, we understand that hydrometeorological phenomena is one of the most, I would say, most important threats in cities around the world. First of all, because the magnitude and frequency of rainfalls and also other events such as hurricanes, monsoons, and typhoons has raised dramatically from the past 10 years, causing not only economic but also social damages cities worldwide. This is also it has become a matter of national security in different countries, not only in Mexico or in the US, but pretty much also Asia and Italy. To understand flood risk, we had to go back to history, and there are three types of flooding. First one coming from the sea, the second one, river overflow. Cities usually establish themselves next to the rivers for agriculture and other purposes. And by the time they grow in size, and this risk has been exacerbated by different situations and features. And the third one is coming from extreme rainfall, when the city is not the sewer system is not adapt enough for peak discharges. It's flooded, maybe because the drainage capacity is not enough or it's not well constructed. Also, this is a problem when you consider the citizen factor. If we are not well educated, if we, put the trash and we block the inlets where the water goes, it's going to be flooded. So this is also a problem coming from our culture. On the other hand, we have hydraulic models. Hydraulic models help us to understand the flood risk in cities. But there's a lot of uncertainties using these models. The type of data we're using, the parameters, also the flood modeler, what is he considering? Is he considering different roughness coefficients? Is he considering the absorption, the types of inflow? Is he using hydrographs as input or rainfall? So all these factors have a direct impact in the results. Here this approach is using the Esri technology, a 1D drainage model, which is SWIM. It's the most common model for the US. Also a 2D quasi-hydrodynamic model. This is Flow 2D, and the component of citizen science and volunteering geographic information. This is the historical center of Palermo in yellow, and the upstream watershed. As we observe, from the upstream watershed, 50% of the rainfall comes from creeks and and discharges from the impervious surfaces. This means that most of the green area has been urbanized, and this is a factor for the flooding in the city. First of all, because the water cannot be infiltrated into the soil, and also the roads and pavement increase the speed and also the flow going downstream. Also, we have the sewer systems. And for this case study, we're using the hydrograph from August 1997. This was the greatest event from the past 25 years. And here we have some information provided by University of Enna Core of Palermo and Professor Gabriel Freni, which help us to develop the model and provide data. And something that really amazed me is that flood risk in the city of Palermo, minor creeks are responsible of this. The Piccoli Fossi, if we go back in time, rivers were in the center of Palermo, but they were blocked and they were constructed on top of the river. So the drainage system not only contains the drainage, but also oil rivers that were originally in the city. I'm not gonna add a lot on the modeling. This is the 1D hydraulic model EPASWIM. It's used the San-Benan equation and is only for confined flows. And then the flow 2D model, which is grid-based, a volume conservation model, and combines hydrology and hydraulics. The flow can move in 8 different directions based on the topography and the roughness coefficient of the surface. Laws and prevention measures are different in Mexico, in Italy, worldwide. And from a regional approach, we can see that in the Sicily region, they're only taking the water depth as a flood hazard evaluation criteria. While if we go to the north, in the Lombardy region, it's not only the water depth, but also the velocity. And this is an important factor because velocity can also affect the infrastructure. And of course, the flow is moving constantly. Here we observe the results. The most affected areas are, without a doubt, Porta di Castro, located here in the center. And we observe that from the evaluation criteria, according to the evaluation criteria of Sicily, it's medium. It's medium, but when we see videos from users from the last rainfall event on 2018, it's impossible to walk in this street. You will definitely draw because of the speed and also the height of the water. And we can also take different examples from the train station and so on. This is a very complex component to work together. The surface modeling and the sewage system. But it's needed to really understand the factors when it is actually flooding. Why is it happening? Does the municipality have to invest money to clean the inlets and the pipes and the sewage system so it could prevent flooding in some areas? Or the capacity is not enough? So this is important to understand, because based on the results, policymakers can adapt a better approach in preventing flooding in the city. We also have not only one product, which could be the pie product from Palermo, but there are also research efforts or from international agencies like the World Bank, in which they invest money they pay scientists, research, and they also want to figure out where are the main areas of flooding in cities and around the world. But which of these products is the most correct? Is it the World Bank? Is it the PI? And the problem is that these entities, at the moment, they're not working together to understand this issue. Maybe a great approach, an innovative approach, will be to integrate the PI product also with the national and the continental product, so we could not only observe at the regional state, but also zoom and like surfing on Google Maps, really understand what's going on and which areas are, let's say, better locations to invest for real estate. It's an idea. I was surfing through the internet the other day, and it's really impressive that in this case from weather Sicily and severe weather Europe, there are videos and pictures in which we can visualize the situation from the flooding immediately based on the time of when the video is uploaded. So these BGI observations can really help us to calibrate and validate the models from the region and at the national level. And this approach, it's available on the web. If we could join efforts with, let's say, social media famous people, for example, I don't know, soccer players or politicians, that they could be behind our initiatives, and asking the citizens to map or to record videos of these events, we'll have an unlimited amount of data to validate and to really understand which areas are more affected by floods and where we should invest, where should improve the quality of life of the city. This approach has not been developed at the fullest by the Esri technology, because there's a social media web app that you can use: Instagram, Twitter, Flickr, and other social media platforms. But eventually, because the digital revolution is just going up, what will we be able to visualize from all time videos of flooding disasters, also helping from keywords search, we could really improve the way we develop results for policymakers to take better decisions. Thank you very much.